In this video, all of our problems have to do with the transformations of functions. In this first problem, we see that we have the basic shape v, which reminds us of our absolute value parent function, which of course looks like this. Now we see that this function is upside down, so we know the beginning is going to be a negative. And we also see that it has some kind of stretch and is shifted right 1. So since it's shifted right 1, I'm going to go ahead and start by writing the equation with y equals, I'm just going to leave the a here, x minus 1. And in order to figure out what number should go out front, I'm going to plug in another point besides the vertex. I'm going to pick this point right here for negative 1. I'm going to plug in the negative 1 for y and the 4 for x. And I get negative 1 equals 3a, and a equals negative 1/3. And now I'm able to write this equation over here, negative 1/3, the absolute value of x minus 1. Now in this problem, you might have also noticed that it's got this linear arm, so you could have pulled out that 1/3, negative 1/3 that is, as the slope down 1 over 3. That only works because this is linear here. All right, for the domain, we can see this function goes forever to the left and to the right. So our domain is negative infinity to infinity. And our range has a top maximum at 0, but then it goes down forever. So our range goes all the way from negative infinity up to 0, and it includes 0. Last thing, we're asked when it is increasing. So if we go from left to right, we can see that our function is going up all the way till we hit 0, but after that it is going down. So we would say that it is increasing from negative infinity to 1. Remember, we use x values to say where it is increasing. All right, on this next graph, we're asked again to write the equation, and we should see that the parent function is the square root of x. I can see that it was shifted left 2, and so I'm going to write the initial equation as y equals a, the square root of x plus 2 on the inside, because it was shifted left 2. I'm going to pick another point right here. I've got negative 1, 2. And I'm going to put that in for x and y to find a. So 2 equals a, the square root of negative 1 plus 2. So that would be the square root of 1, which is just 1, and a equals 2. And so we have our equation 2, the square root of x plus 2. In this case, we could have also found that number 2 by saying, oh, I'm going up 2 and over 1, and if I can do the over 1 and see how far it goes up, I can see a vertical stretch of 2, which would also give me this number. Let's see, domain and range. My domain has to do with the x values. My left x value is negative 2, and then it goes forever to the right. It includes negative 2, so I include that there. And my range, my lowest y value is down here at 0, and then it goes up from there, so 0 to infinity. The next question, when is r greater than 2? Well, 2 is right here, so I'm greater than 2 for the entire part of the curve that lies above that line, which would be from an x value of negative 1 all the way out to infinity. All right, number 3. This time our parent function, of course, is our parabola, which goes through 0, 0 normally, and we see that this one shifted, let's see, right 1, and down 2. So we've got 2 shifts, but we do still need to find a. So we've got y equals a, and so we went right 1, so that's going to be x minus 1 squared, and we went down 2, minus 2. And now I'm going to plug in another point. I think I'm going to go right here with 3, 0, and plug that in. So 0 equals a. I've got 3 minus 1 squared minus 2. Let's see, I'll add 2 to both sides. So I have a 2 over here. 3 minus 1 is 2, squared is 4, so I get 4a, and a equals 1/2. So I've got my equation 1/2 x minus 1 squared minus 2. My equation for my line of symmetry is going to be this vertical line right here. It's a line through x equals 1, so that is its equation, x equals 1. And it asks me, where is this thing less than 0? Well, this is where my y is 0, so it is less than 0 anytime it is below 0. And so that's going to be everywhere from -1 to 3. All right, in this next function, our parent function is y equals 1 over x, which looks like this. We're told there's no stretch, so we don't have to worry about a. So we just have to see what happens. How did it shift? And I can see that I'm going to have one of the asymptotes here. So it shifted left 1, so I'm going to have an x plus 1 down here. And it also shifted down 2, so I'm going to have a minus 2 here. And I know it's 1 on top because there is no stretch. I'm asked to write the equation for each asymptote. This vertical asymptote goes through x equals -1, so that is its equation. And this horizontal one goes through y equals 2, so that's its equation. All right, now number 5 here. This isn't one of our parent functions, it's a polynomial function where we can see the zeros. If I look at this and I look at the terms, I can see I go 1, 2, 3, so I know it's going to be third degree, which means it can have up to 3 zeros. I see one of the zeros here at -4, and I see right here at 2 that this is going to be a double zero. So I can start out writing the equation y equals a, x plus 4, and then x minus 2 squared. And that's how I get that cubic or third degree function. I'm going to plug in another point to find a, and I'm going to pick this point right here, which is 0, 2. So I've got 2 equals a. When I plug in 0, I get 4. When I plug in 0 here, 0 minus 2 is -2 squared is also 4. And so 2 equals 16a, and a equals 1/8. So my equation is 1/8 x plus 4 x minus 2 squared. All right, and then in part B, when is this increasing? So I go left to right again. I can see that I'm going up all the way till I hit this -2, so I'll write that down first. All the way from -infinity to -2. Then I see that I'm going down here, but I'm going up again right here from 2 to infinity. All right, in this last problem, we are told that these are transformations of either e to the x or ln x. So it helps to know that the basic function for e to the x looks like that, and it goes through the point 0, 1, and ln of x goes like this, and it goes through the point 1, 0. Also helps to remember that e to the x has a horizontal asymptote, and natural log x has a vertical asymptote. So when I come over here, I see the vertical asymptote. I know it's the natural log graph. And the asymptote isn't at 0, it's at -2. So it actually went left 2, so that I know my function is going to be the natural log of x plus 2 on the inside because it's a horizontal shift. And my asymptote is right here, this line at x equals -2. In this next graph, I can see that the parent is going to be e to the x. The original function looked like this. So I actually flipped over the y-axis, which means that the negative goes up here with x. So n of x equals e to the -x. And my asymptote never changed. My asymptote is right here at y equals 0.